Good evening, everyone. My name is Kawago Zarani, and we are back to discuss and talk about artificial intelligence in recommendation systems. Um, Now, what's the problem being investigated? People in the modern day movie platforms have a problem with making choices on the movies that they want to watch. Some of them want a comedy, action, what, but you'll find something else. And these movie streaming platforms are doing, they're using AI to recommend movies to the user according to their previous searches. If that user has been there for some time, if it's a new user, and they'll face some problem, like there's a problem there of cold start, that's called cold start, shall see it there in the future. Then what's the background of this? The background of a movie recommendation system. First of all, what's a recommender system? Or a recommendation system is a system that can provide a person with a similar type of products or solutions and results. For instance, you go to an e-commerce website like Amazon, you search for a Rolex wristwatch, then the system will recommend the various designs and types, different colors, and you pick from that. Now, our movie system will also be like that. You go search for the movie, you don't search for, yeah, you search for the movie, then if you search and you're a new user, that data will be being to be kept to be being stored. So when you come back, before even you search, the system will recommend for you movies. If you have been watching mostly or searching for action movies, comedy, romance, what, thriller movies, horror, to recommend. Now, this primary significance of a movie recommendation system is to filter and predict only those movies that are certain users most likely to watch. Let's scope here now the project scope. Now, in obtaining this information, use the IEEE library and go and say I put in the references. You can go and check it out. There's different concept papers and the Springer link, and the keywords we use to find the information were movie recommendation, artificial intelligence, and the K-means clustering. K-means an algorithm, and supervised learning. Shall look at that also in the nearby future. It's an algorithm which is will be used here, and this is our problem statement to help streaming media platforms recommend users favorite movies on the basis of their interests and behavior within the shortest period of time, according to the ratings of the users. These are the research questions. What will our model or which machine learning methods can be applied in recommendation systems? We know that these machine learning techniques or methods can be either supervised or unsupervised, like that. And what data needs to be collected for the movie recommendation system to work? What's the best methods to use? How can you measure the accuracy of this recommendation system for like the accountability? And it's the hypothesis to connect. Just if the K-means clustering can be used to categorize the movies into different groups, the objectives recommend appropriate movies to users according to the ratings of other movies provided in the same cluster. Here again, K-means clustering comes in. It categorizes the movies in different groups. If it's action, if it's this, if it's that, in the same category. And on the business side of this system, it gives as long as possible on the platform as to generate the most possible profits. This is on the side of the organization, for example, Netflix, YouTube. Fulfill the user's needs in the shortest period of time, shortest time possible. The data sets, again, the data sets. We won't change the data set. Shall use the same data set, movie lens, and these are the files. There's 6 files. Also put the reference there. Can then check it out. The methodology. First of all, shall do data collection, and data will be collected through user searches, item views, likes, and ratings. Then data pre-processing. This is done through getting the data set, the movie lens, importing libraries, the NumPy, importing data sets, finding missing data, splitting the data set into training and the test set, feature scaling, then model training. This means determining the good values for all the weights and the bias from labeled examples. You can use a loss function called the squared loss. The squared loss, this is the square of the difference between the label and the prediction. As you can see from the equation there. And then there's model training. Here we are determining the good values for all the weights and already it's a repetition, sorry about that. In model testing, this is where the performance of a fully trained model is evaluated on a testing set. And then lastly, evaluation. This is using different evaluation metrics to understand the machine learning model's performance and all its strengths and weaknesses. For example, accuracy, precision, recall, and the confusion matrix will be used. Confusion matrix is a common evaluation metric. And these are the references, and then check them out. Yeah, thanks for watching.